Welcome once more to Best Science Brain YouTube. Today we are on the chemistry content, tutorial or practical, and today we are going to look at separation technique, a topic meant for those that are doing that are in SS1, in high school 1 or senior secondary school 1, and also it's also useful for those of people in SS2, SS3 that don't have an idea of how to carry out separation techniques. So our focus today will be on separation of a mixture by method of filtration. So we're going to be taking those techniques one after the other in our subsequent videos. Before we go ahead, we will take a little introduction before we go to the practical. What's a mixture? In chemistry, a mixture is a combination or is a physical combination of two or more substances. So when you combine two substances and there is no chemical reaction involved, we say that a mixture has been produced. For instance, you can have a mixture of sand and water, a mixture of common salt and water. Sand and water gives you a mixture. Common salt and water also gives you a mixture, a different kind of mixture. Iodine and ethanol also gives you a mixture. Sugar and water also gives you a mixture. Limestone powder and water also gives you a mixture. Ethanol and water also gives you a special kind of mixture. So a mixture is a substance formed by combining two or more substances when there is no chemical reaction involved between them. So that's a mixture. So we're not going into the theoretical part of this topic, but our focus is on the practical part of this topic. Now, before we go ahead, we have to introduce two major types of mixtures. We have a mixture called solution. We have another type of mixture called suspension. So we're not going to look at solution today, but for our knowledge, the solution is a homogeneous mixture of a solute and a solvent in a single phase. So a solution is a homogeneous mixture. The word homogeneous means uniform mixture of two substances. For instance, we have common salt, which is sodium chloride, plus water gives you salt solution. The common salt is called solute. The solid is the solute. While the liquid in which the solid dissolves is called a solvent. So solute plus solvent gives us solution. Or I can have sugar and water, giving us sugar solution. So sugar is the solute, while water is the solvent, giving us a homogeneous mixture. Why do we say that solution is homogeneous? We say that it's homogeneous because if a substance is dissolved in the liquid known as a solvent, the particles of the substance will not appear again. They will be totally dissolved. The particles of the substance can be called crystalloids. They dissolve and we don't see them again with our naked eyes. For instance, if you visit a friend, a very good friend of yours, and you want to drink water, you enter the house and you call his name. He tells you that he's doing something inside the room. Then you see a glass of water on the table, chilled glass of water on the table. You'll be tempted to drink it. But you may not know, perhaps before you get to the house, your friend may have dissolved common salt or may have dissolved sugar inside the water, and you will not be able to know because you're not seeing anything. That's the solution. I think that's an example of the solution. A typical example of solution. It's only when you test the mixture that you feel that it's only water that you know that something, either you salty to test or you sugary to test, that you know that something was dissolved inside of it. So when you test it, you know that yes, what you're taking is not ordinary water, but it's a mixture. But this kind of mixture is called a homogeneous mixture. A homogeneous mixture. So, or a solution. Now, most solutions are colorless. Salt and water is colorless. That's why we don't know that salt was inside it. Sugar and water is colorless. But the question is, are all solutions colorless? The answer is no. Some solutions are colored. For instance, when you add copper sulfate to water, copper sulfate water will impart, you have copper sulfate solution. Copper sulfate, this substance, has a property of imparting color on water. You're going to be blue in solution. So blue, even though it's a solution, you're not seeing the crystals of copper sulfate when you make the solution, but for the fact that it is blue, implies that something is dissolved inside it. When you take a bottle of mineral drink, perhaps Fanta drink or Coca-Cola, these are solutions. When you look at them, they are colored. You know that actually something was dissolved inside the liquid. But you know that here, even though it's drinkable, but it is not transparent. It's not transparently clear. That is, it's not colorless. But it's an example of a solution. But you're not seeing the substance dissolved inside it. So our focus today will not be on solution, but our focus today will be on the other type of mixture called suspension. Suspension. So a suspension is a heterogeneous mixture of two substances. The word heterogeneous means non-uniform. So what do I mean by being non-uniform? That is, in suspension, the substance will not dissolve in the medium. For example, sand and water. So sand plus water. Sand cannot dissolve in water. So that is a suspension for you, or a heterogeneous mixture. Sand doesn't dissolve in water. So that is a heterogeneous mixture. So you cannot call sand a solute. Neither can you call water a solvent, because you use the word solute and solvent when they dissolve in each other. Or you have clay plus water. Clay particles cannot dissolve in water. You have a suspension. You can have salt like zinc carbonate and water. Zinc carbonate cannot dissolve in water. You have a suspension produced. So these are examples of suspension. In suspension, the substance can dissolve in the liquid. So suspension is a mixture, solution is a mixture. In a solution, the substance has total dissolution, dissolved totally in the liquid. But in a suspension, the substance cannot dissolve in the liquid or in another medium. That is a suspension for you. So having done that, we now ask ourselves, we are looking at the technique called filtration as a separation technique. That is our focus for today's practical class. Filtration. As how do we filter? Filtration, or when do we use filtration? Filtration, it is a technique used to separate in suspension of insoluble solid in a liquid. So use filtration for suspension of solid particles. That is an insoluble in a liquid. Example, chalk dust in water, zinc powder in water, iron dust in water, zinc carbonate in water, powder limestone in water. All these will form suspension. They won't dissolve inside the liquid. So the only way you can separate them is to make use of filtration as a separation technique. So when you want to filter, there are some certain things we do. We'll look at the diagram for filtration. You want to filter, we bring filter stand. We have filter stand, then with a clamp on it, You suspend a filter funnel. We screw the filter funnel you screw the clamp to the filter funnel to make it tighten it as a support for the funnel. We then fold a filter paper and into a V shape or conical shape and then drop it inside the funnel. Then we bring under a beaker, which is a glass vessel. Then we'll pour the mixture that I want to separate here, maybe a mixture of sand and water. Sand plus water. I'll give you some time to filter. The filter paper contains tiny pores in the funnel, filter funnel. Why this one is called a regulator stand. So the filter paper contains some tiny pores that will allow the liquid, that is the water, to drain through it. So water will start draining through the tiny holes or the filter paper and be entering the beaker, while the sand will remain behind. Because sand particles are large enough that they cannot pass through the filter paper. So this liquid we have here is called, this water is called the filtrate. That's the technical name for it. The liquid that we collect after or that percolates through the paper is called the filtrate. While the sand or the salt that remains behind is called the residue. The residue. So this is filtration in action. That is how we can demonstrate filtration in the laboratory. Before we go to the practical aspect of this topic, we need to understand the theoretical aspect of the topic as well. Then, what is the industrial application of filtration? In what kind of industry is filtration applied? Filtration is applied in water treatment plant. Water treatment plant. So, water treatment plant is an equipment used for purifying water, pipe-borne water. Pipe-borne water. So, in this, water is allowed to pass through a bed or a reservoir containing tiny stones and sand packed together. So this reservoir containing sand or tiny stone, fine sand and tiny stone is called sand or stone bed, BED. So water is allowed to pass at high pressure, water containing some suspended particles into this system of sand and stone packed together. Now, this system of sand and stone act as same function as the filter paper. We cannot use the filter paper here because the amount of water we are trying to purify is a very large amount that can be supplied to a municipal or to a town. So, as water passes through, it comes out through another opening. So, water is filtered into another tank. So, we can see that water filtered to another tank. While the particles or the suspended particles inside the water will be trapped by the sand and stone. So only water will enter this container, while the sand, whatever is carrying, whether it leaves or debris from the sea or river from where it's gotten, will be trapped inside this system of sand and stone while water passes through. So what is being done here is filtration in the industry. So this is an example of filtration application in water treatment, in what's called water treatment plant, where water is being filtered. So now we'll go to the practical aspect and then go to the practical aspect of this topic and then understand filtration for the practical concept. We're now going to look at filtration, the practical aspect of filtration. I'll have on the board, this is the regulator stand, this is the clamp, this is the funnel, filter funnel. Then inside the funnel we'll have the filter paper. We'll have a mixture of water and zinc carbonate. The solid residue there is zinc carbonate. Water goes through, because the filter paper contains tiny pores. So water filters out into the beaker. So water is the filtrate. Water that passes through the filter paper is through the tiny pores, or the filter paper is called the filtrate. The zinc carbonate, which is insoluble in water, is called the residue. So we'll now we'll go to the practical aspect. Now we have the filter stand here, have the clamp, have the funnel already clamped. Then we're going to place the beaker under the funnel to collect the filtrate. Then here I have the filter pepper. The filter pepper is a pepper but thick. It has a thicker than ordinary pepper. Then how do we fold the filter pepper? To fold it, I'll fold it into two equal halves. So it's into a semicircle. Then after folding the semicircle, I fold again into a cone. So the folding is done twice. So I have a cone. Let me repeat the process again. To fold the filter pepper, you fold first into a semicircle. Then fold the semicircle again into a cone. Hold it at the tip of the cone. You can open this end or you can open the other end. So open one and close one. So you now have a funnel shaped structure. Then fix it into the filter funnel. Into the funnel. Let it lap on the funnel. So we have it there. If it does not lap on the funnel, then you need to sprinkle some water. For this not lapping. So we need to sprinkle some water on the walls of the funnel to act as a kind of adhesive. So sprinkle some water on the funnel and then you stick it back. Put it back in the funnel so that it can lap in the funnel very well. So we can see it from up. The filter funnel is now in the funnel. Then I'm going to make a mixture of zinc carbonate. This is zinc carbonate. The name is written here, zinc carbonate. We use a salt that is inside the water. I'll use a spatula and collect some zinc carbonate into the test tube. Collect more. Then this is our zinc carbonate. Then I'll now add water to the zinc carbonate to form a mixture. As I said, to form a suspension, a mixture of an insoluble solid in water. Because the zinc carbonate is insoluble. Before I filter this, I need to stir the mixture or stir it or I shake it to make sure the particles are well distributed. So let's shake. So you see that the mixture has a white appearance, showing that the zinc carbonate is insoluble in the liquid, in the water. So I'll shake it once more, and then we'll move over to our filtration apparatus to filter out of the from top. And now pour the mixture straight into the filter pepper. And then allow it to drain. You see, the filtrate is coming out gradually. It's coming out gradually into the beaker. So as you can observe here, this is filtration taking place. So as you filter, you watch, you see the level of the mixture is going down, the filter is going out, it's coming out from the filter pepper. I add more, as you can see, you look at the mixture, you see that the zinc carbonate is settling down. This place is thick white, while the place is somehow milky. It's showing that the zinc carbonate is insoluble in water. So I will check again before I add. I add more of it. So it's filtering slowly. We're having a filtrate. The water, having the residue there. Then as this continues to watch, when the level of the mixture decreases, I'll add more of this. Now what I'm going to do is this. Since it's remaining a little solid inside the zinc carbonate, I add more water to the mixture. Add more water to the mixture. Shake it again so that I can rinse the test tube very well, and then empty the mixture into the filter pepper. So you see it's going little by little. Very simple process. So now filtration taking place. Separation of an insoluble solid from a liquid. For you to carry the filtration, the substance will be insoluble in the liquid. So watch as the process continues. So you see it's going on. We're waiting for it to, we're waiting for the whole liquid in the pepper to drain out completely. So that is filtration. One of the simplest separation technique in chemistry. Okay. So it's more like we're almost getting through with the practical of this, of today. Okay, let me carefully bring out the filter pepper. Then we're going to open it on the table. So on the table. So this is the zinc carbonate, which is called the residue. The residue. Why the liquid here is called the filtrate. Residue and filtrate. So as you can observe, see the residue. You also have the filtrate collected. Okay. So probably sometimes you may refilter. If the filtrate is not clear enough, you may refilter the filtrate. So that you have a good separation. How do you refilter? You get another filter pepper. Fold it again into a semicircle. Fold again into a coal. The way I did the first one. Open one of it, then insert it into the funnel. Now I want to refilter this filtrate so that we have a clear separation. In case there are particles of residue that are inside the place, we have to refilter it. Let me use the test tube here now. Then I pour the filtrate inside. This one will be very speedy or faster now. You see, I'm now refiltering the filtrate. So this one is very fast. So that is it. So having done that, you can bring out the pepper and open it once more. We open it once more. You see that there are a little residue on the filter paper, and then the filtrate is clearer now than before. So the filtrate is water. I have to have it on the board there. The residue, which is the one in the paper, is the zinc carbonate, which is retained in the paper. That shaded place is the residue. So you can filter a mixture of or a suspension of insoluble solid from a liquid by filtration. Somebody else can still use grounded limestone and water. You can also use sand and water to demonstrate this. So this is how you carry out filtration. We have come to the end of today's practical. Remain connected to this YouTube channel. And as I said, if you are seeing this video for the first time, go to the channel's name, Best Science Brain. Under my profile picture, you see Best Science Brain. Then under it, you see a small bell with subscription written on it. Tap on the small bell and get subscribed for more videos. So we see this is a basic chemistry, mainly for those who are starting chemistry for the first time. Let's say SS1 students and those who have no idea of how to filter in chemistry. From time to time, we should be demonstrating other techniques like the next one would go to chromatography. We still go to other methods like use of separating funnel and other techniques that are used in chemistry separate mixtures. So thank you and always stay connected.